All right, here we go. This is a video for the geometry placement, section 1, part 3. Make sure you write your 5 steps. If you don't know the 5 steps, you can watch the previous videos or look off your notes. If that's a bit of your homework, you got to dig that up if you didn't already. Make sure you have your name on your paper and your period somewhere. Okay? Now, on the section 3, the last time we got together, I probably have this paper. So now you're going to have to just do the question off of a separate piece of paper and copy it over. So we're going to do question 10, 9x minus 2, 4x plus 13. Take a minute, maybe pause the video and copy that on your paper. So we see 2 terms on the left, 2 terms on the right, and we're trying to get x by himself on one side. So I always say there's 9x's here and 4x's there. So it's much more efficient to move the 4 over here with the 9. You always want fewer things moving, unless it's negative, and those are more negative. So you want as many positive things moving over here. And so I did that, and now I get 5x, and I copy the rest down, and this would be 0, and then I have plus a 13. So that's all that's left on the right. Now, I still don't have x by himself on one side. I got this messing it up and that messing it up. So I'm going to add 2 to both sides. And because these are like terms, I'm going to line them up. And I'm getting close to my answer here. I copy everything down. And the number 5 is still keeping x from being by himself on one side. So I'm going to divide by 5 on both sides, because it is the inverse operation. I get my final answer. Now, I could plug this back in just to make sure. That's another way to do it. So notice I subtracted stuff on both sides. I added stuff on both sides. Then I divided stuff on both sides to get my final answer till finally x was by himself on one side. Question 11, go ahead and copy down. This one's going to be a little bit harder because there's stuff on the bottom. So we learned back in middle school to add fractions, you need common denominators. But this is not the same denominator as that, so I can't combine these. Okay, so what would be another technique is I could multiply everything by 3y, and that would cancel. Okay, but that's not going to cancel here. I'm still going to have a 2. So I think the best technique here is to multiply every term. So this is this term, and this term. If I multiplied every term by 6, and we did this similarly, if this was just a 3 and a 2, a fraction 4/3 and 5/2, if you multiplied everything by 6, that would allow everything in the denominator to go away. So I'm going to multiply everything by 6y, 6y, and 6y. I'm going to multiply every term by 6y, and then we'll see what happens. So when I multiply, and let's just rewrite this, 6y times 4 over 3y plus 6y times 5 over 2y. And 6y times 1 is just 6y. When I do that, notice quite a lot cancels. Y divided by y is 1. Y divided by y is 1. Now we don't have y in the denominator. I can also cancel 6 divided by 3 is 2. 6 divided by 2 is 3. Now I have nothing in the denominator, and that's what I wanted to do. So step 1 was find a greatest common multiple, and the greatest common multiple of 3y and 2y is actually 6y, okay? And notice it worked perfectly. Now nothing is in the bottom. Now I'm merely going to rewrite the problem. So here I found the greatest common multiple and multiplied each term. Here I merely simplified. Okay? And last I'm going to rewrite this. So everything canceled except for 2 times 4. everything canceled except for 3 times 5, and I still have my 6y. So I have 8, 15, 6y. These terms are alike, so I'm going to combine them. So that'd be 23 equals 6y. And I still have y, the number 6, keeping y from being by himself. So I'm going to go ahead and divide both sides by 6. That would cancel. My final answer, I'm going to leave my answer like a fraction. 23 over 6 is my final answer. Next question. I have a system of equation. So that's 2x plus 5y equals 12. 2x plus 3y equals 8. Go ahead, pause, and copy the problem down. Now, the easiest way to answer this, there's more than one way to solve systems, is that if they're lined up appropriately, and they are, I can solve by cancellation or elimination. But notice, I need to multiply every term by a negative 2. Or excuse me, a negative 1. If I multiply every term by a negative 1, this term by negative 1, this term by negative 1, then notice 2x minus 2x is going to go away. And that's what I need. I need one of these variables to go away. So I'm going to go ahead and do this. But first I'm just going to recopy the top line again. 2x plus 5y is 12. That was just a recopy. The next line I'm going to multiply by negative 1. So that was negative 1 times 2x is negative 2x. Negative 1 times 3y would be minus 3y. Negative 1 times 8 is a negative 8. Notice it changed the sign of every term we had. Now, so I'm multiplied, right? Now I'm going to, this is called eliminate. So this goes away. 5y minus 3y, 2y. 12 minus 8, 4. Y is still not by himself, so I'm going to divide by 2y and get y is 2. Voila. Now, this would have gotten you half credit because I still need to know what x is. So either equation, whichever one looks easier, doesn't matter which one, I'm going to plug 2 back in where I see the letter y. So I'm going to pick this one here. I think this one's got a smaller number, so I'm just going to recopy here. 2x plus 3y is 8. Instead of the letter y, we can put the number 2 there because we now know y. We solved the mystery of the y, and we know y is the number 2. So our original equation said 2x plus 3y is 8. I recopied it. I plugged in for y. 2x plus 6 is 8. Couple things keeping x from being by himself. So I'm going to subtract 6 on both sides, and I get 2. So I get 2x. Kind of running out of room, so let me just get a little bit more paper here. Divide by 2 on both sides, and I get x is equal to 2 divided by 2, so x is equal to 1. So my final answer was x is equal to 1, y is equal to 2. Now let's do the next problem. Let me turn it over here. 13. 3x minus 2y is 10. Y equals x plus 3. Now this is going to be special because see how things are not lined up? But what's nice is, notice they've already solved for y. So now that I know that there is an expression for y, I think I'm going to use substitution here. That's going to be a little bit easier. So where I see the letter y, I can substitute an x plus 3. So I'm going to rewrite this. Looking at the first equation, 3x minus 2y. But instead of the letter y, they're telling me I can write x plus 3. Now, like we did in class, to get rid of parentheses, we distribute. So I'm going to distribute the -2 to both terms and rewrite the problem. So I have 3x, and a -2 times x is a -2x, and a -2 times a +3 would actually be, oops, a -3 or a minus, excuse me, a -6. -2 times 3 is -6 or -6. And this number is still 10. So we distributed. Now I have to combine like terms. So notice these two terms are alike. This one is not like they are. So 2x minus, or 3x minus 2x is 1x. And I still have a -6 and a 10. And so this is still keeping x from being by himself. So I'm going to add 6 to both sides. And I get x is equal to 16. Awesome. Now, I can plug back to either one, but this one's pretty easy. Remember, we started with y is equal to x plus 3, and now we solved the mystery of the x. We know x is 16, so I know that 16 plus 3 would be 19, so now I know what 19 is. Thanks for joining us.